In this video, we're going to take a look at section 6.6 on solving equations involving radicals. To solve an equation with a single square root, isolate the square root on one side of the equation, square both sides to eliminate the square root, solve the resulting equation for x, and then check your answers for extraneous solutions. So unfortunately, this process is not foolproof. Sometimes it'll produce answers that don't actually work in the original equation, so we have to check our answers to make sure they actually work. So it's not just good advice, it's a necessary part of the process. You can't trust the answers you're getting. You have to check them to make sure they actually work in the original equation. All right, so let's apply this process to an example. So we have the square root of 2y plus 5 equals 9. We already have the square root isolated to one side of the equation. It's already by itself over here. I mean, there's some stuff in the radical, but the square root is alone on the left-hand side of the equation. And so I think that was step one. I just read the steps and I wasn't, yeah, okay, so that's step one. Step one's already done for us, right? Step two is to square both sides. So I'm going to raise both sides to the second power. So let me rewrite the equation. And then we will take that step two, of raising both sides to the second power. We raise the entire left-hand side to the second power. We raise the entire right-hand side to the second power. And something we have talked about as we've gone through chapter 6 is that nth roots cancel out with powers of n. And so that's going to happen in this case. The square root and the power of 2 will cancel each other out. And so we'll just have 2y plus 5 on the left-hand side. On the right-hand side, we get 9 squared, which is 81. Step 3 is to solve the resulting equation. Now, just like what happened in chapter 5, the same thing can happen in chapter 6, which is once you get through the initial couple of steps, you might either get a linear equation or a quadratic equation. And it's important to be able to recognize the difference between them because you have to approach those equations differently. If it's linear, like it is in this case, we just isolate the variable. We just get y by itself. Move everything else to the other side of the equation. If it's quadratic, we have to get 0 on one side and then factor the other side. You'll know it's quadratic if your variable's raised to the second power and if that sticks around, right? But we don't even have that going on here. So it's just y to the first power. It's linear. So let's get y by itself. We'll subtract 5 from both sides. So we get 2y is equal to 81 minus 5, which will be 76. And then we will divide by 2 on both sides. And we'll get, I'll just write it over here. We'll get y is equal to 35, 38. Looks like it'll be 38. All right. And so we get y equals 38. Then we have to do step 4, which is we have to check that answer. There is a chance that 38 may not actually work in the original equation. I don't think it's very likely here, but we need to check. We just need to be consistent with that last step. Don't just assume this is going to work. Let's check to make sure it actually does. So we're going to take 38, plug it back into the original equation. So we'll have 2 times, in place of y, we'll have 38 plus 5 equals 9. And we have the square root of 2y plus 5 there. So we will simplify inside the radical. 2 times 38 is 76. 76 plus 5 is 81. The square root just copies down. The square root of 81 is 9. And so it actually does work. So this is a good solution. So the solution to this equation is 38. Let's try another problem. So again, step 1 in this case is already done for me. The radical, the square root, is already by itself on the right-hand side of the equation. So we're good with that. It's okay if it's on the right-hand side, as long as the square root is by itself. So we'll go ahead and we'll move to step 2, which is we will square both sides of the equation. So step 2, we're going to square both sides. So I'll square the entire left-hand side and the entire right-hand side. On the right-hand side, the same thing happens as it did in the previous example. The square root cancels out with the power of 2. So those just cancel each other out, and we just get x minus 3 as a result. The left-hand side, however, does not work out so smoothly. We have to square the left-hand side. Now, what you can't do is distribute that power of 2 to the x and to the 9. So this does not become x squared minus 81. I wish it was that simple. Unfortunately, this square means we have to take the base, which is x minus 9, multiply it to itself twice. So we're going to have to write that out. X minus 9 times x minus 9. And if you write it that way, it becomes clear what you have to do here, which is you have to FOIL this out. And so we're going to do first outer, inner, last, right, to multiply this out. So we'll get x times x, which is x squared. X times negative 9, that's negative 9x. Negative 9 times x is also negative 9x. And then negative 9 times negative 9 will be positive 81. And this is still equal to x minus 3. And then we will combine like terms here. So we get x squared minus, I was about to put 81. It should be 18. Minus 18x plus 81 equals x minus 3. And now we need to solve this equation. So step 3 is to solve the resulting equation. So we'll go ahead and continue up here. This is a quadratic equation, right? We do have an x squared here, and that is going to stick around. That's not going to get canceled out in any way. So to solve this equation, we need to get 0 on one side. So we'll go ahead and start that down here. We'll subtract the x over to the left-hand side, and we'll add the 3 to the left-hand side. And so that will give me x squared minus 19x plus 84 equals 0. So you get 0 on one side, then you have to factor the other side. So we need to factor this by finding two numbers that multiply to 84 and add to negative 19. So I'm not really thinking of it off the top of my head. So there's what, 21 times 4. That's not going to give me 19. Let's see, 28. Does 28 work? No, 21 times 4 works, right? 21 times 4. So again, I'm trying to split this up in a different way. So yeah, 28 and 3 would work, but that doesn't give me 19. Let's split it up like this. We'll have, oops, I moved the window that I'm recording on. That's bad. So I apologize for that. It's not letting me move it back either, which is kind of weird. Why did it let me move it in the first place? Well, I mean, it's cutting off these numbers just slightly, but not horribly. So we're going to take the 3 here and the 4 and write that as 12. So this will be 12 times 7, which does give me 19. So not a very obvious one, but 12 times 7 does multiply to 84. It does add to 19. And because we want negative 19, we will have to write this as negative 12 and negative 7. Right. And then we set each factor equal to 0. We get x minus 12 equals 0, x minus 7 equals 0. And then we solve for x in each case. So here we get x equals 12 and x equals 7. All right. So we get two solutions, at least two potential solutions. We don't actually know if they work in the original equation. Like I said, you cannot trust these answers that you're getting. So we have to do step 4, and we have to check both of these. It's possible that only one of them works. It's possible that they both work. It's possible that neither one of them works. So any of those things are possibilities. So we have to check both. So let's check 12. We'll do that one first. So we're checking it here in the original equation. So we're going to plug 12 in for x. So we'll have 12 minus 9, excuse me, equals the square root of 12 minus 3. 12 minus 9 is 3. 12 minus 3 is 9, right? So, and then we get the square root of 9, which is going to be 3. And so 12 works out. It actually does solve the equation. It gives you the same thing on both sides. Let's check 7. We'll get 7 minus 9 on the left-hand side equals the square root of 7 minus 3. 7 minus 9 is negative 2. Let me try that again. Is negative 2. 7 minus 3 is positive 4. The square root of 4 gives me positive 2. Whereas on the left-hand side, I have negative 2. So these actually do not equal each other, which means 7 is actually not a solution to the equation. Only 12 is. So my final answer for this problem is x is equal to 12. That's the only solution. All right, let's move on to the next example. Whoops, I hit the wrong button. Okay. I guess I don't think anything changed. I hit the undo button or the redo button, which I don't know what that would do, but I wish they made these icons a little bit different. They're both, like I mentioned before, the undo button and the previous page button are both left arrows. They do look a little different, but they, when you're not really thinking about it, they kind of mean the same thing in my mind, so I just click on the wrong one by accident pretty frequently. All right. So let's take a look at this example. So the first step we actually have to do this time. We have to get the square root by itself because the plus 2 is over here with the square root, and squaring both sides will not work if we do it right away. So let me just address that mistake, because this is a mistake I'll see students make. They see a square root and they think, okay, I'll just square both sides. And so they start off like this. This doesn't work because that power of 2 is not going to cancel out with that square root because the 2 is in the way. This plus 2 is in the way. You cannot distribute it to each of these. What you would have to do is like we did before. You'd have to take the base, multiply it to itself twice. You'd have to FOIL. It's going to be a gigantic mess. And even after you do all of that, you'll still have a square root in the problem. So squaring, while there's still something in the way, is not going to get rid of the square root. That's why we have to first get the square root by itself so nothing will be in the way. And then when we square both sides, the power of 2 directly cancels out with the square root. So let me erase everything that I just wrote here. And let's start over again with step 1. So if you follow the steps, you'll be fine. But that's why we have to do step 1. You can't square both sides if there's another term here with the square root, because then it doesn't actually cancel out the square root. Right. So first we'll get rid of the 2 by subtracting it to the right-hand side. And so we'll have square root of 2x minus 1 equals x minus 2. So that's step 1. Get the square root by itself first. That way, when you do step 2, which I'm going to do up here, you square the entire left-hand side, you square the entire right-hand side, and now that the square root's by itself, that power of 2 will directly cancel out with that square root, since one is being applied directly to the other. They'll cancel each other out. So this square root cancels out this power of 2. We'll get 2x minus 1 as a result from the left-hand side. From the right-hand side, we'll have to do what we just mentioned a moment ago. Take the base, multiply it to itself twice. So we're going to get x minus 2 times x minus 2, and we'll have to FOIL that out. So that's going to give me x squared minus 2x minus 2x plus 4 when I do first outer inner last. Right. And then we will combine like terms here, and we'll get x squared minus 4x plus 4. This equation is again quadratic because we have an x squared and it's going to stick around. So to solve this equation, we have to get 0 on one side. This time, I'll get 0 on the left-hand side. So I'll subtract 2x over to the right-hand side, and I'll add 1 over to the right-hand side. And so this is commencing step 3. We'll get 0 equals x squared minus 6x plus 5. So this one's a little bit easier to factor. We will find two numbers that multiply to 5 and add to 6. That's going to be negative 5 and negative 1. I kind of misspoke there. Two numbers that multiply to positive 5 but add to negative 6. That's going to be negative 5 and negative 1. And then we set each factor equal to 0 to solve this equation, just like we always do with quadratic equations. And we get two answers. We get x equals 5 and x equals 1. All right. Now we have to check those answers. So you shouldn't think of these as solutions yet. You should think of them as potential solutions, right? They could possibly satisfy this equation, but we don't know if they do. So we have to check both of them. So let's start with 5. So we'll have square root. We'll go back to the original equation up here. We'll have the square root of 2 times 5 minus 1 plus 2 equals 5. So let's go ahead and simplify that and see if the left-hand side matches the right-hand side. So this is going to give me 10 here. 10 minus 1 is going to give me 9. So I get the square root of 9 plus 2 equals 5. The square root of 9 is 3. 3 plus 2 does equal 5. So 5 is a solution. Let's try 1. All right, so we'll plug 1 in over here. we get the square root of 2 times 1 minus 1 plus 2 equals 1. And so we'll get the square root, well, 2 times 1 is 2. 2 minus 1 is going to be 1. And so we get 1 inside the radical. The square root of 1 is 1. And then we get 1 plus 2 equals 1. That's not true. So 1 doesn't work. So only 5 is the solution in this case. It's pretty common when you get two answers that one works and one doesn't work. But it is still technically possible that both of them could work or that both of them are bad. So you really have to continue to check both. Unfortunately, because I think some students on the test, they check one. If it works, then they keep that one, throw the other one away. You really need to check the other one too, because there are equations where you get two solutions. So, all right, let's take a look at the next kind of equation. So there's a couple of these on the homework. There's not a lot. To solve an equation with a single nth root, isolate the nth root on one side of the equation, just like you would for a square root. But this time, instead of squaring both sides, you're going to raise both sides to the nth power to cancel out the nth root. So remember, powers of n cancel out nth roots cancel out powers of n. So we need to make sure the power we're using matches the root that we're dealing with. All right? And then solve the resulting equation for x, and then you should, again, check for extraneous solutions. Now, if it's an odd root, I don't think you can have extraneous solutions, but it's just a good idea to check anyways, just in case. So we'll still use step 4 here, which is check our answers to make sure they actually work. All right, so let's take a look at a problem like this. So step 1 is already done for me. Isolate the radical on one side of the equation. So the cube root is already by itself on the left-hand side. Step 2, well, let me rewrite the equation first. Sorry about that. So we'll have the cube root of x plus 9 equals 5. To cancel out that cube root, we will have to raise both sides to the third power. If it was a fourth root, we'd raise both sides to the fourth power. If it was a fifth root, we'd raise both sides to the fifth power. All right, so because it's a cube root, raise both sides to the third power. The power of 3 directly cancels out that cube root, and so we just get x plus 9 on the left-hand side. On the right-hand side, we have 5 to the third power, which is 125. And then step 3, solve the resulting equation. This is a linear equation. We don't have x squared, so all I need to do is get x by itself. I'll do that by subtracting 9 to the other side. So we get x equals 116 when we subtract 9. And so that appears to be the solution, but let's go ahead and check just to make sure it actually works. So we're going to plug this back into the original equation. We'll have the cube root of 116 plus 9 equals 5. 116 plus 9 is going to give me 125. And the cube root of 125 is actually 5. So we do get 5 equals 5. So 116 is a valid solution. All right, we're going to take a look at a new kind of problem that you will be dealing with in this section. And this one, these kind of problems are pretty tough. They take a while to get through. So yeah, just do the best you can with them. And just keep in mind, don't get discouraged. These problems are pretty tough. So these are equations that have 2 square roots. I know it doesn't sound like that'd be too tough to deal with, but they are fairly difficult. They take quite a bit of work to actually work out. Isolate one of the square roots on one side of the equation. That's the first step. We're going to at least get rid of one square root to get things started. So get one of the square roots by itself. Then you will square both sides. That will cancel out the square root you isolated, but it doesn't cancel out the other one that's floating around in your equation. So you're going to get rid of one, but the other one's going to stick around, and it's going to be a mess when you simplify squaring both sides. Then you'll have one square root remaining in your equation, so you will isolate the remaining square root on one side of the equation again, square both sides again to cancel out the remaining square root, and then the square roots will be gone. You solve the resulting equation, and then you have to check your answers for extraneous solutions because you cannot trust the solutions you're getting from this process. You have to check that they actually work in the original equation. All right, so let's try one of these problems. So we have the square root of y minus 3 plus the square root of y equals 3. My advice, because you're going to get rid of one of these square roots right away, I would get rid of the worst looking one first. We don't want to deal with one that looks really bad, right? We want to get rid of that one first. So I'm going to isolate the scarier looking one first. I'm going to isolate this one. So this is step one. Isolate one of the square roots by subtracting this square root to the other side. And so I'll get the square root of y minus 3 equals 3 minus the square root of y. So I've isolated one of my square roots. Then, step 2, I'm going to square both sides. So I square the entire left-hand side, square the entire right-hand side. That power of 2, in this case, directly cancels out that square root. So you'll get y minus 3 on the left-hand side. On the right-hand side, unfortunately, like I said, I wish we could do this. You cannot distribute that power of 2. That'd make things so easy if we could, but it's not how math works. What we have to do is take this base, 3 minus the square root of y, and multiply it to itself twice. And we're going to have to FOIL. And so you'll do first, outer, inner, last. So 3 times 3 is going to be 9. 3 times negative square root of y is going to be negative 3 square root of y. Negative square root of y times 3 will again be negative 3 square root of y. You just put the number in front of the radical. And then this one we have a shortcut that we really will have to use on these problems. It's not so bad in this case, but it can be really bad in some other problems if you don't know the shortcut. Negative times a negative is positive. That's what I meant to say. Square root of y times the square root of y. We learned this earlier in the chapter. When you multiply a square root to itself, the square root just goes away, and you get whatever's inside the square root as a result. So square root of y times the square root of y is just equal to y. So you should definitely use that shortcut with these problems, especially as these equations become more complicated. All right, so now we're going to combine like terms. I'll just continue up here. So we have y minus 3 equals 9 minus 6 square root of y plus y. All right, that's combining these two together right here. So as promised, we square both sides. One square root gets canceled out. We have to FOIL the other side, but after you simplify things, you only have one square root left in your equation. So now we want to get rid of this square root, and to do that, we'll have to isolate it. So get this square root by itself. We'll start by getting rid of the plus y by subtracting y to the other side. Get rid of the 9 by subtracting the 9 to the other side. Now this is actually best case scenario for this kind of problem. The y on the left-hand side cancels out with the y on the right-hand side. Sorry, I had my directions backwards, but when I subtract the y over here to cancel it out from the right-hand side, it also cancels out from the left-hand side. That's the best thing that can happen for these problems, because now we have actually a pretty simple equation. We're going to have negative 12 over here equals negative 6 square root of y. All right, everything else just kind of went away or simplified in some other way. So again, we want to get the square root by itself, so let's get rid of this negative 6. We'll divide it to the other side. The reason we're dividing is because these are being multiplied together. To cancel out a multiplication, we divide. And so we're just going to get 2 equals the square root of y. So again, this actually simplifies to something very easy to work with. Now to get rid of this square root, so I guess I lost my steps here. So step 3 was to isolate this square root. Now that I have, step 4 is to square both sides again. So I'm going to square the left-hand side, square the right-hand side. This power of 2 cancels out this square root, leaves me with just y. And then on the left-hand side, 2 squared gives me 4. Step 5 would be solve the resulting equation, but it comes out already solved for y. So we already have step 5 kind of automatically done. And so the answer appears to be 4. This is a potential solution. We still have to check. So step 6 would be check this answer in the original equation to make sure it actually is a solution to the equation. So we'll have square root of 4 minus 3 plus square root of 4 equals 3. All right, so I'm plugging 4 in for y, and then I'm going to simplify to see if the left-hand side actually does equal the right-hand side. And so 4 minus 3 is going to be 1, so we'll get square root of 1 plus the square root of 4 equals 3. The square root of 1 is 1. The square root of 4 is 2. And 1 plus 2 does equal 3. So 4 is a solution to this equation, is the only solution to this equation. All right. So like I said, a little bit more work when you have to deal with 2 square roots. This is, like I said, the easy version of this problem. And I'm not trying to say the problem's easy at all. It's still a hard problem. But this is the easier version of this problem. There is a hard version of this problem that's going to be about twice as bad as what we had to just do here. And let's see if we have such a problem with this example. So we have the square root of 4y plus 12 minus the square root of y minus 6 equals 6. All right, so first step, isolate one of the square roots. I like to isolate the scarier looking one, which again is the first one in this case. So I'm going to leave this one over here on the left-hand side so it's isolated. And I'm going to move this square root to the right-hand side. So I'm going to add square root of y minus 6 to the other side. And so we're going to get the square root of 4y plus 12 equals 6 plus the square root of y minus 6. So that's step one. Isolate one of the square roots. Step two is to square both sides. So I'll square the entire left-hand side, square the entire right-hand side. On the left-hand side, just as we've seen with every other problem we've done so far, the power of 2 cancels out directly with the square root, and we'll just get 4y plus 12. So one square root is gone. On the right-hand side, we're going to have to FOIL. You're going to have to write this out, multiplied to itself twice. 6 plus the square root of y minus 6 times 6 plus the square root of y minus 6. And you're going to FOIL, right? So you do first, outer, inner, last. First would be 6 times 6, which will be 36. The outer terms would be 6 times the square root, which will just be 6 times the square root of y minus 6. The inner terms, you get the same thing. The square root times 6, we'll just put the 6 in front, and the square root of y minus 6 after it. And here's where this shortcut is really necessary, right? So positive times a positive will be positive. Square root of y minus 6 times another square root of y minus 6 is just going to equal y minus 6. That when you multiply a square root to itself, it cancels out the square root. And you get whatever's just, keep saying, I feel like I'm saying the words in the wrong order there, but the square roots cancel out and you get whatever's inside the radical as your result. If you don't use that shortcut here, it can get pretty tough to figure out. All right, the left-hand side is just going to get copied down. And then I'm going to combine like terms. So we'll have 4y plus 12 equals 36 minus 6 gives me 30. And then these two terms in the middle are like terms because they both have the same radical. So we have 6 and 6, which will be 12 square root of y minus 6. And then the plus y just copies down. All right, so what I'm going to do is copy this and paste it to a new page to continue working on it because there's still quite a bit of work left. So let's go ahead and snap a picture of this here. Let's see if I can get this right the first time. All right. We'll put it on a new page. Okay. So now we're going to continue working on this. So if we go back to the previous page, so this was step 2 still, I guess. We haven't really started on step 3 yet. All right. So step 3, which we're going to start on now, would be to isolate the remaining square root, right? We still have one square root left in our equation, so we need to get that square root by itself and then square both sides again to cancel out that last square root. So all this stuff around it needs to get moved to the other side. So I'll start by subtracting the y, and unlike the last example where the y's just canceled out, which made the equation so much easier to finish out, that doesn't happen here, right? The y's are not going to cancel. This is going to be the hard version of this type of problem. We'll also go ahead and subtract the 30 over here. And so what we'll end up with is 3y minus 18 equals 12 times the square root of y minus 6. Now, I struggle with this every time I teach this topic, what to do with this 12, because if you take me literally, you have to get the 12 out of there to get the square root by itself. But mathematically, it's actually okay if the 12 just stays there. You can square both sides. It'll make the square root cancel out. You'll just have to also square the 12, which gives you 144. But I get worried about students being able to handle that well. The alternative's not much better, though. So I'm just going to stick with the way I normally do it, even though, again, this isn't 100% necessary. There's actually one benefit we can get out of doing it the way I usually do it. So get rid of the 12. Again, it's being multiplied to the square root. by dividing the 12 to the other side. And this is the way I usually do it. The reason I hesitate on that is because it does make a fraction. That doesn't completely cancel out. But we can reduce it. And by reducing it, we can make the number smaller, which is a good thing. So maybe that's the benefit of just go ahead and divide it over here, make a fraction. Yes, that kind of stinks, but maybe you can reduce the numbers and get them to be smaller. All right, so the 12s cancel out. We'll have 3y minus 18 over 12 equals the square root of y minus 6. Now what we can do to reduce this, you have to think back to chapter 5, right? This is a rational expression. You can only cancel out factors. Thankfully, I don't know, I mean, coincidentally, I don't know the right word to use here, there is a common factor in the numerator, which we can factor out that does reduce with the denominator. The common factor is 3, right? So let's factor out a 3. We'll have y minus 6 left over. And then the 3, now that it's a factor, can be canceled out with a 12, which is by itself, so it's automatically its own factor. And that'll leave me with a 4 in the denominator. So it's still a fraction, but the numbers are smaller. And that's going to help us here in just a minute. So we have 4y minus, sorry, I don't know why I said 4. We have y minus 6 over 4, I guess that's where I meant to put the 4, equals the square root of y minus 6. So that was step 3, getting the square root by itself. And then step 4 is to square both sides again. We square the entire left-hand side. I'm just like stuck on 4 now for some reason. We square the entire left-hand side, square the entire right-hand side. On the right-hand side, that power of 2 directly cancels out that square root. So we just get y minus 6. On the right-hand side, or sorry, on the left-hand side, I'm all scrambled up here. We apply that power of 2 to the top and bottom of the fraction. So we'll get y minus 6 squared on top. We'll get 4 squared on the bottom. And so we have to simplify that. So I'll write this out because, again, to square it means we have to multiply it to itself twice. So we get y minus 6 times y minus 6 on top. On the bottom, we get 4 squared, which is 16. And I'm sorry, I feel the same way. My 4's and my y's kind of have some similarities, so I apologize, but that is a 4 there, right? So 4 squared gives me 16. This is a y, so this will still be y minus 6. So what we're going to want to do, and we might as well do it now, is we want to get rid of the fraction. I don't want this to stay a fraction any longer than it has to be. So multiply the common denominator to both sides to get rid of the fraction. So we'll multiply by 16. That makes the 16s cancel out. We have to multiply it to the right-hand side as well. And because there's 2 terms there, you need to put parentheses there. And we're going to go ahead and FOIL this out. So first, outer, inner, last. Y times y is going to be y squared. Y times negative 6 will be negative 6y. Negative 6 times y is negative 6y. Negative 6 times negative 6 is positive 36. And we'll go ahead and distribute the 16 here. So we get 16y minus 96. I don't know why I happen to know that off the top of my head, but 6 times 16 is 96. And now we need to solve this equation, right? So step 5 is to solve the resulting equation. It is quadratic because we have y squared, which is going to stick around. So we would have to solve this by getting 0 on one side and factoring the other side. I'm going to resume this problem on yet another page. So we're going to have to go to page 3 here on this problem. Before I do, I want to just go ahead and combine like terms here. So y squared minus 12y plus 36 equals 16y minus 96. So we're going to solve this equation. Let me snap a picture of it. I'll use my mouse. I think that'll work better here. And I think that should work. Put this on a new page. All right, so this is step 5 now. We're solving this resulting equation, which is quadratic. We'll get 0 on one side, so we're going to subtract the 16y, and then we're going to add the 96. So you should be pretty glad at this point that we reduced that fraction, because if we didn't, these numbers would be a lot bigger, and this would be something that looks more difficult to factor. All right, so we're going to get y squared minus 28y, still a pretty difficult thing to factor as it is. This is what it can be, 2, carry the 1 over, so 132, I think, is what that would be, equals 0. And so we're looking for two numbers that multiply to 132 but add to negative 28. Yeah, nothing's coming to mind for me. I think 132 is 11 times 12. I'm pretty sure 11 times 12 is 132. Let's check the calculator to see if that is indeed the case. Calculator, 11 times, this is kind of silly, I should know this, but yeah, that is 132. Okay. Now, of course, that doesn't add up to 28, so you might just dismiss that right away as, okay, that doesn't work. But we can split up the 12 as 3 times 4 and try to regroup these things to see if there's another way we could write it so that it does add up to 28. And 3 times 4 actually doesn't look like it's giving me anything, right? We could get 33 times 4 or 44 times 3. Neither one of those add up to 28 either. Another way to write 12 is 2 times 6. And so I think this is going to be more promising. So that'll give me 22 and 6, which does add up to 28. So think of something that does multiply to 132, and then try to take those smaller numbers and split them up in different ways and recombine them. I think that's an easier approach than just trying to keep thinking of numbers that multiply to 132. All right, so those are the two numbers I'm looking for. So this will factor as y minus 22 times y minus 6 equals 0. We're going to set each factor equal to 0, and then solve for y. And we finally get some potential solutions. So after all of that work, you would think that we could be more certain about our results, but we actually can't be. So we get 22 and we get 6. But we don't know if those are actually solutions to the original equation. So we actually have to check our answer in the original equation to make sure it works, even though we already did all this work. So we still have to do step 6, which is to check these answers. We'll start with 22. So we need to go back. I've already forgotten what the original equation looked like. So let's go back and see if I can remember it long enough. So it's square root of 4y plus 12, square root of y minus 6 equals 6. Let's see if I can remember that. Square root of 4y plus 12, square root of y minus 6 equals 6. And I believe we were subtracting here when we started the problem. So we're going to plug that number into the equation. So we get the square root of 4 times 22 plus 12 minus the square root of 22 minus 6 equals 6. This is going to give me 88. 88 plus 12 is 100. So we'll get square root of 100 minus the square root, subtract 6 out of that, you get 16. So square root of 100 is 10, minus the square root of 16 is 4. 10 minus 4 is 6. So 22 actually is a good solution. So we keep that one. Chances are we're going to end up throwing away the 6, but we can't be 100% certain about that. So let's check. All right. We get square root of 4 times 6 plus 12 minus the square root of 6 minus 6 equals 6. Right, this actually might be a rare case where they both work. And so I kind of warned you about that before, and it's kind of funny because I'll make these warnings and then they never show up in my examples. But when I warn you about something, it's true, so you want to keep an eye out for it. But finally, in my example, I actually have something that illustrates the thing I'm warning you about. So 4 times 6 here is 24. 24 plus 12 will be 36. And 6 minus 6 is 0, right? The square root of 36 is 6. The square root of 0 is 0. 6 minus 0 does equal 6. So actually, both of these solutions work. That's why you have to check both of them. You can't just assume because one of them works, the other one automatically doesn't work. They can both work. So this equation has two solutions. All right, let's take a look at another example. So here we have the square root of x plus 10 equals negative 6. So this one actually is a really quick problem if you recognize something that I'm about to tell you about here. Whenever you take the square root of a number, let's try that again. Whenever you take the square root of a number, let's say like 25, the square root of 25 is 5. The square root of 49 is 7. Now we haven't talked about this yet in chapter 6, but in a couple of sections we will talk about, even if you take the square root of a negative number, square root of negative 25, that's not a real number, but what it actually is going to equal is 5i. But the answer is still positive 5i. So what I want you to notice is that for square roots, the answer is always positive. So square roots cannot produce negative answers, which is why this equation is problematic, because we have this square root here, and they want this square root to equal a negative 6. That's impossible. There's no way for a square root to equal a negative number. It'll either equal positive numbers or imaginary numbers that are positive, but it never comes out as a negative result. So if they give you an equation and the square root is isolated, right? You have to have the square root isolated before you can make this assessment, and it's equal to a negative, there's no solution to that equation. So right away I can tell this equation will not have a solution. So no solution. So we don't have to even bother working on it. We don't have to square both sides. We don't have to solve for x, because no matter what you get for x, this equation can never be true. No matter what you plug in for x, you'll never get square root to equal a negative number. All right, so that's that example. So here's the last example for this lesson. It's another two square root problem like we were just doing a minute ago. And so we will follow those steps. So step 1 actually is already done for us, right? Step 1, isolate one of the square roots. This square root is already isolated, so let's take advantage of that. I'm just going to rewrite the equation down here for step 2. So step 2 is to square both sides. So now that we have a square root isolated, we can go ahead and square both sides. And what happens on the right-hand side is that power of 2 cancels out that square root, and we get z plus 3. On the right-hand side, we're going to have to FOIL, so we get 3 plus the square root of z minus 12 times 3 plus the square root of z minus 12. I really didn't leave myself enough room for that. Hopefully you can read that okay. So we're going to FOIL to simplify this. So the outer terms, we get 3 times 3, which is 9. Sorry, that wasn't the outer terms, sorry. The first terms, 3 times 3 is 9. The outer terms is going to be 3 times the square root, which will be positive 3 square root of z minus 12. Sorry, I feel like I'm not writing the minus signs very good there. Okay. Right. The inner terms, it's the same thing. Positive times a positive is positive. Square root times 3 will just be 3 times the square root of z minus 12. Plus, here's where we need to know our shortcut, square root of z minus 12, I'm in trouble saying these words, times another square root of z minus 12 is just going to be z minus 12, right? The square root gets canceled out, equals z plus 3. So we'll go ahead and combine like terms. We have 9 minus 12, which will be negative 3, plus the square roots are like terms. We have 3 and 3, which will be 6 square root of z minus 12, plus z equals z plus 3. We still have a square root left in our equation, so we need to isolate this square root. We'll move all this other stuff to the other side. So I'm going to add 3 to the other side and subtract z to the other side. And this is the easy case again, right? Because the z's all cancel out. And so the equation I get here is 6 square root of z minus 12 equals 6. Right. Then we'll divide by 6 on both sides to get the square root by itself. So we get the square root of z minus 12 equals 1. And then we square both sides again. Now, I've kind of stopped numbering things here, so let me go back. Square both sides, solve the resulting equation, or sorry, isolate the remaining square root. That's step 3. That's what we just did here. Step 4, square both sides again. So we're going to square both sides again. In this case, the square cancels out the power. So I'm saying the wrong thing. The square cancels out the square root, and we get z minus 12 equals 1, because 1 squared is still 1. And then we solve for z by adding 12 to both sides. And we get z is equal to 13. So that's step 5. Solve the resulting equation for the variable. We'll solve it for z. We get z is equal to 13. Then we have to check our answer here. So I've kind of run out of room on the screen. So let me see if I can just kind of squeeze it in up here. So this will be step 6 up here. We're going to plug in 13. So I'm going to plug in 13 here for z, 13 here for z. This is going to give me 13 minus 12, which will be square root of 1, equals. This will give me 13 plus 3, which is going to be 16, so square root of 16. And we'll still have this here, 3 plus that equals that. And so even though we only got one answer here, you have to check it because it's possible it doesn't work. And if you have to throw away all your possible solutions, which didn't happen today because it's not going to happen here either, then you would have no solution. And that is a possibility. You might have to throw away all of your possible solutions. And if there's nothing else it could be, then you conclude that the equation has no solution. All right, so here we're going to get 3 plus 1 equals 4, which is true. Right? So actually 13 is a good solution. So we'll keep it, and that's the solution to this equation. So that concludes the video on section 6.6 on solving equations involving radicals.